Hello and welcome to this tutorial about SICK's patented imaging technology Surface Plus. In this video, we will give you a simple overview of what a Surface Plus is, how it works, and how to set it up using the PC software Stream Setup. Let's get started. To understand what Surface Plus is, we first need to understand that our 3D laser triangulating cameras can capture three types of data: range, reflectance, and scatter. Surface Plus is an imaging technology based on the scatter data. Scatter data is normally used to measure how much the laser light is spread or scattered in different materials. This is done by measuring the intensity of the laser at a distance from its peak. With Surface Plus, we further increase this distance on one side, so we don't measure the light from the laser at all. Instead, we add an external light to illuminate the area where we collect the scatter data. By adding an external light, we can better see surface details that cannot be captured in the regular 3D or reflectance data, such as scratches, painting defects, or engravings. The intensity of the external light is collected at a fixed distance from the laser, which provides a 2D image that is automatically aligned with the 3D data. For this demonstration, we will use the SICK 3D camera Ruler3000 and an external LED line light. The object that we will inspect is a battery case, and the goal is to get 3D data of it while also capturing a good image of the engraved data matrix code. I will show you how to connect and set up the light and how to configure the Surface Plus parameters in Stream Setup. First, we are going to make a normal scan of the battery without the Surface Plus technology. As you can see, we get a nice 3D image. But if we look at the reflectance data, it lacks contrast between the code and the shiny surface. We will now use Surface Plus to make the code more readable. In Stream Setup, enable and open the Surface Plus tab. In this tab, we can configure all the relevant parameters. Start by pressing Set Parameters. This will enable the scatter component and set all Surface Plus related parameters to recommended initial values. Then start the camera and expand the Light Extraction tab and enable the visualization of the extraction window. The light blue area shows the intensity values around the laser from the selected column on the sensor. The dark blue area represents the rows from where the light will be extracted. The extraction region can be modified in the Light Extraction Region tab. Next, we want to select from which side of the laser the light should be extracted. We will use the default position front, which means the light will be extracted above the laser. The width is the number of rows that we measure the light from, and the typical value is between 2 and 4. When we change it, we can see that the extraction region changes. The offset refers to the distance between the laser peak and the area where the light is being extracted from. We want the offset to be as high as possible to avoid disturbance from the laser line when extracting the light. Now this area is dark, but the light will later illuminate it. The next step is to set up the external light. The Surface Plus technology can be used with various lighting sources depending on what features you want to enhance. It is important that the light strength is adjustable, either through timed triggers or by setting a steady analog level. The light we use in this setup is adjustable through timed triggers, and we will utilize the camera output Laser Strobe 2 to control the light. If you are using a CDB connection module, Laser Strobe 2 is located at pin number 21. Then we need to configure the light in Stream Setup. In the Surface Plus tab, open the Light Strobe Controls section. The light will be controlled by a timer by default. The timer duration controls how long the light is active during each exposure. This must be shorter than the exposure time, and we don't want the light to be stronger than the laser light. Therefore, we will start with a low value of 10 microseconds. If we start the camera and look at the sensor image, we can see that the light is now activated during the profile triggering. Next, we need to adjust the position of the light. The surface of this battery is shiny. Therefore, a specular geometry is most suitable for the setup. In a specular geometry, the camera sees the reflection of the light in the surface of the object. The reflected light will be very bright as it is reflected directly into the camera. If the surface is irregular, such as in the data matrix code, the light reflectance will be disturbed, so not as much light will be reflected in that area, making it appear darker in the surrounding surface. To achieve a specular geometry, aim the light towards the laser and start with a slightly steeper angle close to the camera. Then increase the angle and move the light slightly away from the camera. We can see that the light gets brighter and brighter until it gets darker. At this point, move back to the position with the brightest light, and here you have found the perfect specular angle. In the light extraction section, we can see the intensity of the light we are measuring. The peak visualization button helps to see where the laser line is detected and where the light is being extracted. It is also important to set the tightest possible region of interest to avoid unwanted reflections from external light. Now we can go ahead and make a new scan. If we look at the scatter data, we can see that the data matrix code is now more visible and has higher contrast compared to the reflectance data. However, if we look at the 3D data, we can see some noise where the camera detected the external light instead of the laser, because the light was too bright or the laser was occluded. To solve this issue, we can either increase the exposure time to make the laser brighter or dim the light. To dim the light, lower the timer duration in the light strobe control section. When we dim the light, the scatter image will get darker. So in order to collect the same amount of light as before, we can increase the width of the extraction region. This means that the light is collected from more rows, and the consequence of this change is that the scatter data becomes less sharp. It is a compromise that we must do for this type of complex object. If we make a new scan, we can still see the data matrix code clearly in the scatter data, and the 3D image has less noise. Obtaining 3D data and detailed 2D images of a surface has traditionally required two separate cameras, but with the Surface Plus technology, this can be obtained using only one camera and an external light source. Additionally, you receive all data in the same coordinate system. So now you have both a 2D and 3D image, and you are ready to integrate the Surface Plus technology into your own solution. Thank you for watching.